All right, next let's look at square roots and simplifying expressions with square roots. So let me give you the basic form when we're talking about square roots. So let's let n be a natural number and b to the n equal to a. Then what we say is that b is the nth root of a. So when we say b is the nth root of a, we're kind of referring to this equality. So for example, with 5 squared equal to 25, remember 5 squared is equal to 5 multiplied by itself twice. That's equal to 25. So this middle part isn't being written here. So with 5 squared equal to 25, we would say that 5 is the second root of 25. So here we have 25 has 2 roots of 5. Okay, so 5 is the second root of 25. And when we say the words second root, we can also say square root. So a square root is denoted by this radical sign, which kind of looks like that. In order to help you understand how to apply a radical sign, understand that a radical sign around a number is the same as having that number with an exponent of 1/2. So this is like really important, being able to interchange these two. The square root of b is the same as writing b to the 1/2 power. Now right here, we're only talking about square roots, but to kind of make this point a little bit more, you can have something like a third root of a number. And so that would be the same as having that number to the 1/3 power. Or if you had the 5th root of a number, that's equal to that number to the 1/5 power. And if we had the 10th root of a number, that's that number to the 1/10 power. Okay, so I just kind of did this, not because you're going to see this a lot, but to kind of draw this connection with the root of a number and how that translates to a fraction as an exponent. So given that 5 squared equals 25, we can algebraically take both 5 squared and 25 to the 1/2 exponent like this. So if we took 5 squared, and that's equal to 25, and if we put both to the 1/2 power, okay, that doesn't break anything algebraically, because what we do to one side, we do to the other side. And so on the left-hand side, when you have the exponent 2 to an exponent of 1/2, so we have an exponent to an exponent, then 1 multiplies the exponents. So it'll be 2 times 1/2, which equals 1. And 5 to the 1 is just 5, so we're left with just 5 on the left-hand side. So all of this simplifies to just 5 on the left-hand side. On the right-hand side, it's just going to be 25 to the 1/2 power, like that. And so on the right-hand side, we can treat 25 to the 1/2 power kind of going in this direction. And we can treat 25 to the 1/2 power as the square root of 25. And so now we can write this earlier equivalence here. Let me use a different color. This earlier equivalence, 5 squared equals 25. We've now done a little bit of algebra to write it as 5 is equal to the square root of 25. So that's kind of how we interchange between the definition of an nth root, square root, and back and forth. So the square root, to kind of say what we've got here, the square root of 25 is 5. So we can translate that now to simplifying expressions with square roots in the exponents. So here's the definition of the square of a number. So if we have a number squared and that's equal to another number, then m is the square of n. So here we have m squared equals 100. 100 is the square of 10. Then the square root of a number. So again, we have this equivalence. We can say that n is the square root of m. So n is the square root of m. So just kind of going in the opposite direction. And again, we have square root notation. So if we had the square root of some number, so the square root of a, this reads the square root of a, where this is the radical sign, and this is called the radicand. The radicand is just some number or variable that sits inside of the radical sign.